The table shows the average or the mean monthly temperature of a certain location in degrees Celsius. The temperature in January, on average, it is 17.8 degrees Celsius. In February, it is 17.9 degrees Celsius on average, and so on. First, grab the data. From the table, we can determine the appropriate viewing window of the graph. We don't need to go all the way to the negative or below the horizontal axis. We just need to have 12 tick marks on the horizontal axis starting with t equals 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we can make t equals 1 January, but alternatively we can make t equals 0 be January. And so t equals 1 represents February, t equal 2 represents March, t equal 3 represents April, and then May, t equals 5 represents June, and t equals 6 represents July, t equals 7 represents August, t equals 8 represents September, t equals 9 represents October, t equals 10 represents November, and t equals 11 represents December. And again, we can make t equals 1 represent January if we want to. The lower temperature is 9.5, so we only need to start from 9. This is not drawn to scale. And the higher temperature is 17.9, so the maximum we need to go is 18. 9, 10, 11, 12, 13, 14, 15, 16, 17, and then 18. 9, 11, 13, 15, 16, 17, 18. We then plot the points using the data. In January, the temperature is 17.8. We won't be very accurate, but at least we should try our best. In February, the temperature is 17.9, not 18 yet, so we would go up a little bit. In March, the temperature is 16.6, 16.6, and then in April, the temperature is 14.4, 14. In May, the temperature is 12. In June, the temperature is 10.2. In July, the temperature is 9.5. In August, the temperature increases to 9.9. In September, the temperature is 11.3. In October, the temperature is almost 13, 12.9. In November, the temperature is 14.5. And in December, the temperature is 16.4. And so this looks like a cosine model because it starts high, it then goes to the middle, low, and then middle, and then high. And that is the graph of this data. The equation of the sinusoidal function's cosine is y equals a cosine of omega t minus c plus b. In this case, we will use cosine because the graph looks like it starts high, and then middle, low, and then middle, and then high. Although eventually we will have to find the model sinusoidal. A is the amplitude. The amplitude, by definition, is the distance from the middle to the maximum. But trying to estimate the middle using the data is not a preferred method. The amplitude, since it is from the middle to the maximum or the minimum, it is half of the distance from the minimum to the maximum. but half of the distance from the minimum to the maximum is 1/2 of the max minus the min. We can easily identify the max and the min from the table. The maximum temperature is 17.9 and the minimum temperature is 9.5. 1/2 of 17.9 minus 9.5 is 4.2. So the amplitude is 4.2. In this case, we will use positive 4.2 because of the shape of the cosine function. The midline B is the average of the minimum and the maximum because it is the number right between minimum and maximum. And so B is a half of the max plus the min this time, which is 1/2 of 17.9 plus 9.5 or 13.7. And so don't estimate the midline, compute it. It is the average of the max and the min. And so we found the parameters A and B. We still need to find omega and C. We always save C, the horizontal shift, for last. Omega is always 2 pi over the period, but this period is 12 months, so it is simply 2 pi over 12 or pi over 6. If it is pi over 6, leave it in pi over 6. Do not use decimal. And so far, the equation for this model is y equals 4.2 cosine of pi over 6, and then t minus c. We haven't found c yet, and the midline is 13.7. We still need to find the horizontal shift, but remember, the graph of cosine should start at high, and so when t equals 0, that should be where the graph starts, but it looks like it is shifted to the right 1 unit, and so c equals 1. The height was supposed to be at t equals 0. On this graph, the height starts at t equals 1, and so the horizontal shift is to the right 1 unit, and so the equation is y equals 4.2 cosine of pi over 6 t minus 1 plus 13.7. So we're done with the cosine function. To rewrite it using the sine function, the amplitude is the same, but this time we use sine. Pi over 6 t minus, we don't expect to have the same horizontal shift if sine function is used, and so we still need to find c, and the midline is still 13.7. Whether we use sine or cosine, the amplitudes are the same, the frequencies is the same, and the midline is the same. What difference is the horizontal shift in this case. Without the horizontal shift, the graph of sine will start in the middle, and then high, middle, and then low, and then middle. This is the 5-point techniques to graph sine. Without the horizontal shift, the maximum occurs at t equals 3. But we want the maximum at t equals 1. From the data, we see that the maximum 17.9 occurs at t equals 1. And so for the maximum to occur at t equals 1, we would need to shift the graph of sine to the left 2 units. And so the sine equation is y equals 4.2 sine of pi over 6 t minus negative 2 to the left plus 13.7, or y equals 4.2 sine of pi over 6 t plus 2 plus 13.7. If we were to graph this function and the cosine function, we would end up with the same graph.